All right, so actually just kick off iPXE, and then let's go over iPXE and zero-touch provisioning. So a little bit of what Akshat touched based upon, right? The evolutions of the iOS XR stacks since we initiate the 6.0, which is a completely redraw of the software architecture. We wanted to bring a lot of the constraint that existed before into something more. So I wanted to break it down a little bit into three parts. The first part is what we're doing right now. We are iPXing the box. We are just let it to boot, which was difficult in the past. You probably had to do a manual update or an upgrade from the system. And then after that, you wanted to enable services on the box, where it's deploying a Docker container, your own applications, and configuring services, etc. And then finally, the monitoring of the box. As soon as the box is ready and switching packets back and forth, you wanted to have full visibility over it. You wanted to monitor and troubleshoot the box. And all of that, in the past, we're coming with quite of a pain. Bringing up the first two operations of initial bring up and service provisioning could take a long time. And sometimes you had to resource to tickle script and stuff like that to make it work. And then analyze this through SNMP was kind of a pain as well to map the correct MIP to what exactly you wanted to monitor. So coming from the web customers, we wanted to adapt this to a faster speed. So we are doing for the device onboarding, so from the truck to the rack, power on, should be done automatically. No hands-on keyboard at that point. And for that, we set up ZTP, or zero-touch provisioning framework, and of course, iPXE. So, and I'm going to go there in a few minutes. Then after that, of course, as you want to deploy services and configure and manage the box, we want it to be compatible with toolings that exist in the data center, like Ansible, Chef, Puppet, and also netconf applications if you want to use Yang models to configure the box. We wanted to bring that. And then as monitoring and analysis, we wanted to have deltas as short as possible. We wanted to have a push mechanism that push data as fast, control plane data and data plane data as fast as we can in a good format that is both human readable but also machine readable and interpretable. This Akshat will cover probably the day one. We're going to see a small demo of Ansible configuration using a Yang model. And then Victor will finish with telemetry.
Now, do you guys actually have the modules developed for like Ansible and all that integration?
We do.
Yeah, we do.
So the Ansible modules.
So you're contributing back to Ansible and all that, right?
Yeah, so we've been maintaining the Ansible modules for a while.
Okay.
The Ansible core modules will be ready by around March timeframe, I'm told. So some of them are already there, but like things like the netconf modules were created by us. Now they will be incorporated into Ansible core in March.
Yeah.
Cool.
Same thing for Puppet as well.
Okay.
And Puppet and Chef has a package dedicated for iOS XR. You can download it from their website. We work with them to make sure that they integrate perfectly with it.
They provide their client RPMs.
Yeah.
Okay.
Yeah. So iPXE. So we moved away from the traditional BIOS 32-bit to a 64-bit UEFI firmware. That gave us a lot of capability, right? We can now boot from USB key disks directly if you want to. And we wanted to open the bootloader. And in this case, we settle on iPXE. So iPXE is an open source a boot firmware. You can download it on ipxe.org. You can download ISO image. You can they even provide ROM if you want to update your old NICs. It's fully backward with PXE, which is the de facto standard in the data center environment, but come with a bunch of stuff that is really make it a little bit more modern than the traditional PXE that rely solely on TFTP. This one uses HTTP. And you can control the boot process via scripts and menus. So we support, for example, what a dynamic URL for booting. Your DHCP server will give you a boot file that contains a series of variables. The system knows this variable, like the serial number, the PID, or the MAC address of the management interface, will fill that up and do an HTTP GET by filling up all those variables. So dynamic URL, it's one cool thing that you can do. You can chain load your boot event. So you can have a master iPXE boot that you pass, which is just a script actually, written in iPXE scripting language, which resembles to PHP. And from there you can chain load, so based on certain aspects. So it will try to get a file that match the serial number or his host name, or eventually his PID, or stuff like that, and then it will collect the right image from that script. And if everything fails at the end, you can still bring up a menu. And from there, the operator can select the image he wants and download it. So they have a lot of enhancement bringing from the original PXE that are now available in iPXE.
Are you going to, so the thing about PXE boot is it was never really standardized, but we converged on something.
Yeah.
So are we able, like, if I'm deploying a data center and I've got 3,000, 5,000 servers, PXE boot is absolutely necessary.
Yes.
But I might only be installing half a dozen NCS routers. Do I really need a process which is not PXE? Or, I guess I'm struggling to understand why I would auto boot an NCS router.
So
In that sort of, what's the use case for auto booting an NCS?
Building a complete.
For a limited number of volume of devices.
even if it's a limited volume, I guess most of it is about classification of the devices. Now, in server land, it's fairly simple because it's cattle that you're booting up, right?
Yeah.
But in case of the network devices with each role having a separate identifier, the classification that this process affords you, you can have specific images go to specific devices with specific scripts running on specific devices.
Yeah, no, I get that. Yep.
Right. So a lot of the classification exercise is what actually the web guys do. So even if they have like 10 devices, they can just set it up and forget. And the entire bring up of the system is centralized. So for them...
Yeah, no, I get all of that. I understand what I'm doing. I don't understand why you would invest money putting this process together for what seems to be a corner condition, barring a... why would I don't reboot my NCS routers?
This is for building other things.
Well, it is usually for provisioning and upgrades that some people use it. So I mentioned about the truck to rollout times that have particularly changed in the web customers.
Yes, sure.
That's shortened to around 15 minutes for a lot of these guys. So they get it off the truck, get it into the system, and no one logs in.
Yep.
Right?
Yep.
Now, you need that to be automated, which means that the process of image download, if it doesn't come with an image, as well as the config or script needs to be automated, right?
Sure.
So the reason they're doing that is they don't want to make any mistakes, and two, the entire process of manual intervention is slow.
No, I understand all that.
So that's one aspect, the truck rollout. The other aspect is also upgrades. So a lot of folks do not like the idea of trying to upgrade a running box by making sure that they back up everything from the system. So by creating a centralized system beforehand, when you do the upgrade the next time, all they do is, hey,
the upgrade is actually just a reboot.
It'll come back.
There's
with
only
the
one
exact
process for bringing up a router, and it's a reboot and a wipe, a reboot, and a restart.
So in fact, the upgrade use case is what we've seen some of the traditional large-scale service providers moving to now.
Yeah.
They realize that it allows them to centralize their state of the
They
network.
only have to develop one workflow, not multiples, right?
As well as like a reset, like if you wanted to rebuild an environment, you could trigger it through this and
Sorry,
reset.
I didn't mean to derail you. I was just struggling to
that's good,
understand
because that's-
what's the value of this to me as a client.
It has an additional value that I'm going to get to the next slide,
sorry,
or a few slides down the road. Right? Our distributions right now of iOS is in form of an ISO.
Yeah.
And it contains a mini, all the necessary components. We call it the mini ISO because it contains no packages per se. So you still have to install your SPF, your SIS, your K9 package if you want a triple DES, security, manageability package, etc. But what you can do, you can actually take that ISO image, and we provide a tool that I'm going to talk about, and then pack all the packages you want, your configuration on top, and reform the ISO, and that's the ISO you're going to distribute to the box.
Yeah.
Comes to
So the box can come up pre-configured from the get-go. And using iPXE, you can, for example, correlate that to its serial number.
So is there any plans to standardize this across Cisco more widely?
That'd be
So
nice.
the challenge we have with Cisco is just because iOS XR is doing this, we have to learn this is a special banana case for you guys, but not with XE or iOS or, you know,
Yeah,
Cisco's
like
lack of
got-
standardization on these features becomes a real issue in the field because we don't know which and where's and where.
Right, you've got PoEP running on Nexus, on NXOS.
Yeah.
It's like
PoEP is
similar.
equivalent to ZTP, yes.
Right,
Yeah.
but it'd be lovely if I could have one system that we could put in for whatever the system,
This
whatever
looks
the.
great.
Yeah, it
I
does.
like this idea, like, you know, I could treat all of my network switches in my data center this way. Like I should be able to do this to my Nexuses. Instead of upgrading them, I should be able to just iPXE them and load a new image.
Right, because I'll tell you
At
what,
ACI
for a
should-
hardware swap,
Yeah,
if you do a hardware replacement, ZTP is phenomenal.
yes,
Plug it in and it just comes up.
sure. But
Running the right code,
I'm just
the right
struggling
config.
to, yeah.
That's going to be a lot more likely on an NXOS box
But,
than
you
an
know.
iOS XR box.
Yeah, it's-
You'd hope.
It's a two-stage process in a way. One is, of course, within Cisco, but also within the industry. So the industry has had ONI for a while, which is an equivalent for iPXE from
Yep.
Cumulus. But at least the way these systems are designed is that there is no Cisco sauce here.
Yeah.
There is, yes, a library to configure XR, which is always going to be specific to XR. However, the initial process of exchange with the DHCP server, etc., mimics the ONI workflow pretty much, right? So it is.
So why not just use ONI? Or
well-
extend ONI and contribute back?
Well, we could, but iPXE in itself is also a standard within the industry, right? So they're both standards used by different folks for different purposes. It is the server land uses PXE,
Yes.
and by giving iPXE on these boxes, it gets you one workflow for servers and devices.
I guess, yeah.
Yeah.
Yeah, I don't want to get into ONI at this point. Yeah, I support V4 and V6. So then the next part of it is zero touch provisioning framework. So it is actually kicked at the end of the boot process. It's kicked by XR itself, but it executed inside the Linux shell. So that's important. And it's executed automatically if the box has no configuration whatsoever. We actually have a check for that. And then it's automatic. You can invoke it by hand at the CLI. If you already get your hand, the first thing that actually an iOS XR box asks you when it boot up fresh is a username and a password to configure a username and a password and then give you the prompt. So that's the first thing it checks. Is there a username configured? If there is none, ZTP kicks in. Now, if you already logged in, we have a set of CLI that you can invoke a ZTP manually. We call it one-touch provisioning at that point, and you can do that as well. So it relies on DHCP. We provide tons of options in the DHCP. Actually, it's very rich DHCP environment. We provide the serial number, the PID. We provide the hardware release version, the MAC address of the management, etc., are actually provided in different options. And what we expect from the DHCP server is option 67, boot file name. It can be in IPv4, it can be in IPv6. And then from there, we can kickstart the script. So the scripts themselves, they can be in Bash or Python. We support both at this point. If you run shell script, you have access to the full Linux environment of the container, of the control plane container, the XR container. If you run Python, we provide you around 54 package available, including URL lib, for example, if you want to use libraries to configure your systems. If you want to do HTTP GET within your script, you can do that as well. We have curl, we have awk, set, you name it, and grep. All of that is always available, or you have an equivalent Python library for it. Now, we also provide you a set of helper functions. If it's a script, you have to source that helper function. If it's a Python, you have to embed the library, you have to include the library, and that gives you access to the XR configuration, right? And yeah, so this, okay, so yeah, I removed that slide. Sorry for that. So, and what is it gonna really do is give you capability to visualize output or to configure things. So what are the ZTP functions? At that point, you can do pretty much everything with it. You can apply a configuration if you want. You can perform software upgrades. You can install packages or applications. You can deploy container, and Akshat will showcase a demo on that. And you can execute Python and shell scripts. So this is a little bit of the workflow. I don't want to spend too much time on this, but there's a series of verifications that are occurring. What is really interesting is that it uses actually the same flow as iPXE. So we use an option 77 in the DHCP to differentiate between the two phases because they come from different clients. The DHCP clients of iPXE is not the same as the one as ZTP. So we basically give the DHCP server option 77. We mentioned we are in config mode at that point, and then the DHCP server with a simple if statement can actually decide to provide you a file rather than an ISO. And actually, if it's badly configured, we have a check there. The file is bigger than 100 meg. Yeah, something got wrong, and we cut it off right there. Now, if you just want to apply a static configuration from the get-go, you're allowed to do that. You just provide just a configuration in place of a script, and then that's applied. It goes through the parser, so verify for syntax error and commit error, then it's applied. If there is an error that is non-locking, it will spit out a syslog saying, okay, for example, this interface does not exist in the system. You wanted to put an IP address in your configuration. I cannot do that. I spit an error log, but I apply the rest. Right? If it's a script, then it's going to start executing the script within the Linux shell environment. And then it has access through or TPNNS infrastructure to all the interfaces, like Akshat just showed you. And then it can download whatever he wants, right? From there, it can download additional script, it can download packages, it can deploy containers, and it can also apply configuration.
Yeah, so just as a pointer to that, when you're executing the script, it's running in the kernel and, in the user space for XR bash. And the primary requirement there is that applications are able to use the user space to do whatever they want. I mentioned that earlier. The script is basically nothing but an application, right? So it is downloaded, and whatever you want to do in the script, you're allowed to do it, right? You're basically root at the time.
You're root at that point, yeah.
Do you guys, do you have Terraform integration as well?
Well, not
Have you seen a use case for it yet?
Not yet, but would be interested in chatting maybe.
Yeah.
All right. So that just a few examples of what's in the helper function. This is for the shell. You have access to XR command. That's just a way to do a command like show running config or show interface brief if you want. You can do XR apply, and if you do an XR apply, that will merge a configuration block provided in a specific file inside the system. You do replace, XR replace, that will actually replace a complete configuration block with the one you're providing. And then these two you can do with XR apply with reason. That's basically putting in the configuration log an event that you specify. You say, for example, ZTP has done this, and you can track that in the log. You can also do XR apply string, where inside your script you just pass the command straight inside, and of course you can do it and also syslog it into the configuration history of iOS XR. Same thing with the Python library. It's exactly the same command. There is nothing different here, so whatever you choose to write your zero-touch provisioning script in shell or in Python, you have access to the same primitive function to access iOS XR. Right, so that was the question coming from iPXE when I presented iPXE. If you look at the deployment process with a traditional stock image, and then from running, it's actually still a serial process, right? You boot your ISO, you install your package, your smooth for iOS XR, which is basically bug fix. Then finally, when your system, if it needs to reboot at the end, you have to reboot, and then you apply the configuration if you have to. If your package or smooth don't require reboot. You can skip that test, but you basically go sequentially. Now, you can do that in parallel. And in parallel, we provide inside, actually, and on GitHub, we provide a Python application. We call it the Golden ISO Builder. And with that, outside the box on any Linux systems, you just set of requirement. You have to have a set of packages installed prior to that. You can open the ISO, then pre-install all your SMU and packages or your third-party applications if you have to. Apply a configuration candidate, and then repackage it inside the ISO. So, and then you can deploy that image that is now tailored for your specific need. Whatever package you wanted to have, K9, you want to have OSPF and ISIS, you can just pre-put that. And now you deploy that just as a single package to the system through iPXE. Your system come up pre-configured already. You can do that through USB as well, or you can do a system upgrade if you want to. So the important thing is because this golden ISO process still keep the signature of all the packages intact. Whereas if you do it without this application, you may corrupt the signature of the ISO and the system will refuse to boot. Also, so ZTP is essentially a technology that comes from the data center because it relies on the HCP. We are actually looking towards a different type of environment to deploy this, and we already are able to perform in a layer 3 ring. We support the HCP proxy and the HCP snooping, for example, things like that. We are looking towards a layer 2 ring with integrations of dynamic VLAN discovery, where the ZTP script will tag the traffic with the correct VLAN by dynamically discover the VLAN of the neighbor. So we have this capability as well. And that's coming up in a few months with the next release, major release. All right, so we have this heavily documented inside our XR docs websites. It's a good source of information. There's tons of examples of scripts in Shell or in Python that do different things. Actually, I think this presentation will be published there. I wrote quite a few, Akshat wrote quite a few as well. So if you want to know more, feel free to go to those links for your reference.